Alright, so this video is going to be on derivatives of trig functions. I went ahead and wrote down all 6 of them, so you can pause the video and copy them down. Just like we've said with other derivatives that we've learned shortcuts for, these derivatives you're going to memorize, and there's proofs for all of them. If you're interested, we can look back at those proofs and see where these came from, but for us it's just going to be quicker for us to memorize these instead of derive the derivative every single time. Alright, so pause the video, write those down. And then we're just going to do several examples so that we can see how to use these little shortcuts, and eventually you'll get pretty quick with them once you have them memorized. So we're going to do several examples, and the instructions are just going to say find the derivative. They might also just say differentiate, so anything like that. So first problem we're going to do is y equals x squared minus 1/2 cos x. So when we find the derivative for this, we're going to say y prime equals, and the derivative of x squared is just 2x. And then we know when we have a coefficient for something, we keep that coefficient with the derivative. So I'm going to say negative 1/2 is a coefficient that's going to stay. And then if I look up here, I can see that the derivative of cos is negative sine x. So I've got negative sine x right there. And so that means that my final answer for my derivative is 2x minus plus 1/2 sine x, because we had a negative being multiplied by another negative. Alright, for the second problem, we're going to do y equals sine x tan x. And you got to watch out for these because that's actually the product rule. You have sine x times tan x, and there's no way for you to rewrite it, so you can avoid the product rule. You just have to do it. So we're going to say that our derivative is the first times the derivative of the second. So the first is sine x. The derivative of tan x is secant squared x. So sine x secant squared x plus the second times the derivative of the first, and the derivative of the first is cos. And that is it. We don't have to do anything else. Actually, that's a lie. We can simplify this a little bit. So I wouldn't fault you necessarily if that's all you could see. There's a little bit of simplifying that you can do right here, and that was kind of the purpose I had for you in on your summer assignment when you had to do some problems where you were dealing with like trig proofs and remembering the different identities and what things equal what. Because if you look at tan is actually sine x over cos x. And if you're multiplying it by cos x, that is a simplification that you can make. I wouldn't necessarily mark you down if you did not simplify your answer like this. However, on a multiple choice problem on the final, or on the AP exam, I mean, you might not realize that that was the actual final answer because you didn't simplify. So it's just good practice to try to do it on every single problem. Again, if you were doing a test for me, that would get you the majority of the points, leaving the tan in there. So their equivalent answer is just a little bit of simplifying to be done. Okay, let's do another one, problem 3. F of x equals x sine x plus secant x. So again, in the first part, x times sine x, we have a product rule happening there. So I have to remember the product rule, there's no way to avoid it here. So I'm going to say the first times the derivative of the second. The derivative of sine is cos, plus the second times the derivative of the first, which is just 1. And so we've got the derivative of this first part done. Now we just have to do the derivative of secant, and the derivative of secant is secant x tan x. Oop, okay. So final answer, we can't simplify any of that, I don't think. Nope. So our final answer, we're just going to write it without the parentheses and the 1 right there. So I'm just going to say x cos x plus sine x plus secant x tan x, and that's our answer. All right, we're going to do another type of example. We're going to say, actually I'm at the end of the page, let me go to the next one. I'm going to say for this example that we are going to find the second derivative. So the original function is going to be x times cos x. So as you can see in this problem, we have a product rule. So I'm going to go ahead and find the derivative of that using the product rule. So I have first times the derivative of the second. The derivative of cos is negative sine, plus the second times the derivative of the first. So that means that if we simplify our first derivative, we have negative x sine x plus cos x. All right, now we need to get started on our second derivative. So if I look at our second derivative, I can see that I've got a product rule, and then I've got a little bit more going on. So I'm going to say my second derivative is the first times the derivative of the second, which is cos x, plus the second times the derivative of the first. And so that means that this part right here is done. And then on the end I have cos, and I'm taking the derivative of cos, and that is negative sine. So that means that if I simplify my second derivative, I have negative x cos x, and then I had one negative sine x right here and another negative sine x right there, and so that gives me negative 2 sine x. All right, we're going to do another type of example here. So the example says, where does the function and it's secant x divided by 1 plus tan x. So where does that function have a horizontal tangent on the interval 0 to 2 pi? So we have to kind of interpret this question so we know what math we need to do. So when it says horizontal tangent, that means they're looking for a line that goes through exactly one point on the curve, not more than one, just one. And when it goes through that point on the curve, it has a slope that's going to give that tangent line, like it's going to make it perfectly horizontal. So since we're talking about slope, that means we're talking about derivatives, and a slope that's going to be perfectly horizontal is going to be a slope of 0. So they're basically asking us in this question, when does the derivative of the function equal 0? So we're going to go ahead and take that function, secant x over 1 plus tan x, and we're going to take the derivative of it, and then we're going to set that derivative equal to 0 and solve. Now the fun thing about this is the quotient rule, right? Because that original function is a fraction. So we have to do low d high, so the bottom, times the derivative of the top, minus the top, so minus high d low, the top times the derivative of the bottom, and the derivative of the bottom is going to be 0 plus secant squared divided by the bottom squared. Okay. So our derivative here is a fraction, and when we need a fraction, that derivative, to equal 0, we don't care about what the denominator is, we only care about what the numerator is. So if the numerator of a fraction equals 0, then the whole fraction equals 0. So that means we're taking that top part and we're making it equal 0. So for the top, I'm going to go ahead, I'm going to simplify this some. I'm going to, let me show my work here. I'll do green. I'm going to take this and I'm going to distribute it to those two pieces. So that gives me secant x tan x plus, and then secant x tan squared. And then after we have that minus, then we've got a secant x that's being multiplied by a secant squared x. And so that gives us minus secant to the third x. Okay, and we know that to solve that, we have that equals 0. So when I look at this, it's almost like I've got two different variables because I have two different trig functions, but I can see that I kind of have like a GCF of secant x, so I'm going to go ahead and pull that out and see what I can work with after that. So that gives me tan x plus tan squared x minus secant squared x. So that made things a little bit more simple. That means I already have one of my solutions kind of getting started down here. I know that secant x equals 0, right? Because I'm factoring this. I don't know if you guys can tell that I'm factoring this. I'm going to go ahead and make a substitution here because that stuff in the parentheses will be easier to deal with if it's all in terms of tan. And I know that secant squared and tan squared actually do have a relationship. So I'm going to go ahead and switch back to purple. So this secant squared I can go ahead and replace with 1 plus tan squared. And that is one of the Pythagorean identities. So now inside my parentheses I've got tan x plus tan squared x minus 1 plus tan squared. Alright, so if I go ahead and distribute that negative, that gives me negative 1 minus tan squared. And you can see that your tan squared here and your tan squared there actually cancel out. And this still equals 0. And so we're left with tan x minus 1 equals 0. So that simplified pretty nicely. And so that means that here, the solution that we have from this is that tan x equals 1. So this is where we start to look at our unit circle. So let me get it. You guys, I don't remember how to move this. Oh, there we go. It's like, this is not helpful. Okay. Gosh, I'm bad at this game. Okay, here we go. There we go. Okay, so we are looking on our unit circle for where tangent, so where y divided by x equals 1. So there's two places I can see that the y divided by the x are exactly the same right there, and they're exactly the same right here. So those are two solutions for the first one that we were doing. So we have x equals pi fourths and 5 pi fourths. And, oops. There we go. Those are two valid solutions because they're on the interval from 0 to 2 pi, and that's all that I had to check for. So that's good. Over there, when we're dealing with the secant x part, I'm going to switch back to green, we know that secant we're not typically looking for on the unit circle, so I'm going to write this as a fraction. 0 over any sort of number, it doesn't matter. I'm just going to put over 1. So we know that on the unit circle we would actually be looking for cos. So I'm going to say we're looking for where cos is 1 divided by 0 on the unit circle, and we're looking for where cos is undefined, and that does not happen on the unit circle. So that means we don't have any answers for that particular factor. So our only answers are pi fourths and 5 pi fourths. Okay, we're going to do one last example, and then this video will be done. So here, we are going to find That notation means the 27th derivative. We are finding the 27th derivative of f of x equals cos x. So that's the original function. The first derivative is negative sine x. So if you take the derivative of cos, that's negative sine. The second derivative is negative times the derivative of sine, which is cos. The third derivative is negative times the derivative of cos, which is negative sine, so that's negative sine. The fourth derivative is the derivative of sine, which is cos, and we are back at the beginning. All right, so first derivative, second derivative, third derivative, fourth derivative, fifth derivative, sixth derivative, seventh derivative, eighth derivative. So what you might notice is that every multiple of 4 brings you back to the original problem. So that means that if we have a multiple of 4, or if we have a remainder 1 after our multiple of 4, then the answer is going to be the first derivative. If we have a remainder of 2, if we have a remainder of 3, and then if we have no remainder. So here I'm going to take 27 and I'm going to divide it by 4 to see how many times we need to cycle through that situation. So 27 divided by 4 is 6. That gives us 24, right? And so that means that we have a remainder of 3. And so our answer here is going to be that the 27th derivative is the same as the third derivative, which is sine x.